Hi, welcome back to another episode of Real-World Serverless, a podcast where I speak with real-world practitioners and get their stories from the trenches. Today, I'm honored to be joined by Alex Wood from AWS. Hey, Alex, welcome to the show.
Thanks for having me on.
So, you've been with Amazon for just over 10 years now, and you just told me before the show that you should be getting your red badge instead of the normal orange badge. How does it feel?
It was definitely a little bit surreal. I joined Amazon out of college, about 10 years, 24 days ago, according to our internal tracking of that. And joined directly out of college in the retail inventory planning side of things. So my running joke is if you go to Amazon and something is out of stock, there's some chance you could possibly blame me for that in a small way. After that, I spent a little over 5 years on the AWS SDK for Ruby team. And late in my time with the Ruby SDK, I got the opportunity to go and develop the Ruby runtime for AWS Lambda. And I think after that experience, I realized this is really what I want to be working in. I'm really excited about the space and excited about what we could do for serverless tooling and really making the most seamless experiences possible. And so I moved over to working on open source tools for Lambda and the entire serverless space full time.
So your day-to-day focus now, I guess, is with the SAM framework, and you guys have recently gone live with 1.0. So what's changed with SAM 1.0 compared to before?
Sure. So over the last few months, we've been releasing a number of new features. So we kind of had a step back and ask, what are the big changes that could be breaking to the user experience in some way that we would want to do someday? And we got into some interesting ideas like, for SAM init, for example, in the SAM CLI, which creates a new project, we wanted to go with a default interactive experience, which is a small breaking change because if you were expecting SAM init with no parameters to fail, and then suddenly it's an interactive prompt, could be a problem in some cases. So we did that ahead of 1.0, and we added new features like guided deployments and enhancements around a number of small details around building. And a lot of the overall purpose of moving to 1.0 is to give confidence in the operational stability of SAM in the SAM CLI. We want to tell the story that if you use SAM in the SAM CLI for your critical production CI/CD pipelines, your production services, that you can rely on these scripts to work the same way going forward. And generally, the move to GA is a way to signify that sort of operational promise. And so we kind of started working through our backlog of changes to behavior that we wanted to do. And once we got to the end of that, it was time to go GA.
And with SAM and the CDK both positioned as official first-party tools from AWS, what would be your advice on when a customer should use SAM versus CDK? Do you guys have some clear distinctions in mind in terms of you should use SAM and you should be using CDK?
So I think a big part of it comes down to personal preference. I've talked to customers who are very excited about defining their infrastructure in programming languages like TypeScript or Python, and CDK can be a good choice for that. Even like talking to a number of customers who've used CDK to prototype a template and who might, though, prefer to use YAML. There are definitely a number of customers who prefer to write their CloudFormation directly one-to-one in CloudFormation's YAML or JSON formats. But I think for SAM versus CDK, I think where SAM can really shine is when you're building a serverless application in particular. So we have a lot of operationally stable, proven constructs around making the experience of building Lambda functions, integrating them with API Gateway, integrating them with event sources, and making that as seamless and simple as possible. It's also true that it's not a one-way door. So if you get to the point where you feel like you're integrating a lot of other services and you like CDK constructs for those services, there's always the ability to integrate CDK into your infrastructure as well. So some of it is personal preference, and some of it is, if you're really serverless focused, that SAM can be an excellent choice for that.
So do you have some examples of customers doing that? By that, I mean the integrating CDK with SAM, because they both offer some abstraction layer on top of CloudFormation. But I haven't seen anyone using them both. It's always either one or the other based on, like you said, personal preference.
Yeah, I have seen cases where people use the CDK with the SAM CLI. So the SAM CLI does have support, for example, for doing local invokes of Lambda functions that are defined within CDK. I haven't heard of too many cases of people using SAM and CDK together. I think if people are interested in that, that's something I would love to hear about.
Okay, so switching back to, I guess, just focusing on SAM, are there any other interesting use cases that you've heard about from your customers?
Yeah, sure. So I think when you start thinking about SAM and serverless, there's a few classic use cases. So the most common, and I think because this is where a lot of the examples start, is I'm creating some sort of web service or web API, and people are using API Gateway, they're using Lambda, they're often using DynamoDB behind that. There's obviously the other common use case, which sometimes adds to that, of I have asynchronous jobs. So I'm using SQS, I'm using SNS. One interesting thing that I've seen is use of patterns that have come out of SAM and asynchronous workflows, like event fork pipelines. So a very interesting pattern is if you have some sort of event, could be like a purchase of something or a state change, and you publish that event through the simple notification service. One interesting pattern is you could send that notification to multiple SQS queues or multiple Lambdas to interpret them in different ways. So like event replays or archiving previous events using things like Kinesis Firehose and S3, or like ways to track, like, here's an event that has been a failure of some kind, and you can record it in multiple different places. So the idea of like forking events to have independent workflows on them is another very interesting use case that I've seen work really well with SAM.
And besides signaling this operational promise and the stability for SAM going forward, are there any sort of major vision that you guys have for SAM in terms of features and capabilities?
Yeah, for sure. So the one thing that I also like to point out is that 1.0 is not the completion of all the improvements that we want to make to the user experience. I mean, I think if you look at the long arc of serverless tooling, a lot of this is, here's this space that was brand new as of a few years ago, and we're really trying to make everything as seamless as possible and really listen to where customers are struggling or where they feel like they've come up with an interesting solution that really should be integrated and shared. So, we're not stopping with major feature development after 1.0. So some of the things that are in the short-term pipeline is there are a number of improvements to the build experience that we want to make that people have been asking for in SAM. So I think in the short-term future, there's a lot of feature requests that didn't necessarily need to happen before we could promise operational stability, but are still very important that we want to go out and resolve. And then I think the long arc direction after that is to try to answer the question of how can we make serverless development as seamless as possible? Because in a large sense, and this is what really got me excited about working in the serverless space, I have come to believe personally that serverless is probably the most approachable way to make really operationally sound and really like high scaling, high availability, solidly fault tolerant applications. And so it can kind of be like a superpower for you as a developer to be able to use all these serverless concepts when you're trying to solve a particular technical problem. And what I really am excited about is how do we make that as easy to learn as possible so that you can get all of the best practices in place from day one, like to really reduce the cycle of what you have to learn to kind of achieve the operational and performance promise that serverless offers.
Yeah, I can definitely attest to the fact that the serverless is a bit of a superpower. I spent, was it 10, 15 years now working as a backend engineer. 10 of that was working with AWS and spent so much time tweaking with network configurations, setting up the servers, right sizing machine sizes, and setting up AMIs and all of that. All that is just to write like 2 lines of code that does something very simple. Now with Lambda, that's all I have to write, just 2 lines of code and then put into a Lambda function and I'm done. And I've got all the auto scaling, all the logging, monitoring, all of that out of the box. And I mean, I used to spend 2 weeks just setting up the load balancers and all that. Nowadays, I spend 2 weeks, I can write the new backend with AppSync and with Lambda and DynamDB for a social network. It's amazing how much you can get done with one person compared to how much other stuff I have to do before. It's just crazy.
Yeah, absolutely.
So in terms of, I guess, going back to that same question about vision for SAM going forward, I still use Server Framework as my personal go-to choice when it comes to building serverless applications. Mainly because the Server Framework has got this huge plugin ecosystem. So anytime I want to do something that the framework doesn't support, I can find a plugin that does that for me. And that's one of the things that I find has been missing in SAM for me. Is that something that you guys are looking at potentially addressing in the future to open up SAM so that other people can extend its functionalities?
Yeah, I think the notion of providing useful ways for people to extend SAM's functionality, which I think becomes an extension of kind of like more easily integrating complex applications, is something that we're really trying to look at as sort of like the long arc of how do we make it as seamless as possible to contribute to SAM as well as to build increasingly complex applications on top of it. And I think one thing that we're very interested to talk with customers about, and I'm also very approachable on places like Twitter about this type of thing, is what are the type of extensions to SAM's behavior that people would like to see and that they would like to contribute? Because I think when we work on designing that sort of long-term sustainable model for adding on outside functionality through some sort of plugin model or making it as easy as possible to contribute complex pieces of behavior, that's kind of the key questions. We would like to learn more about what types of use cases people are trying to solve with this so that we make sure we design the right approach.
Okay. And you mentioned that before you joined the SAM team, you were working on the Ruby runtime. Maybe can you also just maybe explain to us what goes into building an official language runtime for Lambda? Because the whole custom runtime makes it seem really trivial, but I know that now, for example, with the Node runtime, you guys have to do a lot of work to make sure that security-wise is all locked down, all very secure, so that there's a lot of things you just can't do in Lambda to sort of introspect the actual server itself. What are some of the things that you guys have to sort of design and be really careful when you're building an official runtime support?
Sure. So going back to my experience writing the Ruby runtime, which is a very interesting experience, and I enjoyed it quite a bit. It is not dissimilar to writing a custom runtime. Like, a lot of the core functionality is the same. Like the execution environment is fairly common across the different runtimes that we provide. So a lot of the decisions that we have to make for an official runtime are around a reliability and predictable behavior side of things. So in writing the Ruby runtime, I think I spent a lot of time on what are all the possible surprise exceptions that could jump out of the stack, and how do we capture that and make sure that the error that a user gets if they're trying to debug why is my Lambda function crashing are helpful. So, maybe something that would normally crash Ruby immediately, can I catch that, give them a backtrace so that they can figure out what they did that may have caused their function to crash. Another interesting thing that I noticed is the decisions around what libraries do you include become very important. So another fear you would have writing a runtime that you want to be used broadly is limiting the dependencies you bring in so that you have a deep understanding of the dependencies that you have, and that you have the highest confidence that you're not going to create dependency conflicts with what the user is going to bring in. Even going back to my time on the Ruby SDK, an interesting note is that for a very long time we had no dependencies in the Ruby SDK that were outside of the standard library that were required, and other than other libraries that we owned that then only depended on the standard library. And this allows us to avoid the case of, we need to do an emergency upgrade of a dependency because, there is a critical bug that needs to be updated. If we don't have many dependencies, you're not going to have that situation come up. Or this dependency doesn't play well with a dependency that is commonly used by other users, and they're just going to be unable to use the SDK or runtime. So a lot of it is just thinking about, how do you support the broadest numbers of customers possible? And I think for writing a custom runtime, like if you're writing it for your own purposes, you don't necessarily have to do all of that, because sometimes you just need a runtime that works for your use case, and that's very valid. But I found a lot of my effort was just thinking very creatively about what are things that can go wrong during the runtime's execution, and how can I make sure that we're not going to have obscure dependency conflicts or errors that will create a frustrating user experience. And so it was very interesting.
I want to take a moment to give a shout out to this week's sponsor, Chaos Search. Chaos Search is the fully managed log analytics platform that uses your Amazon S3 storage as the data store. Companies like Armor, HubSpot, Alert Logic, and many more are already using Chaos Search as a critical part of their infrastructure and processing terabytes of log data every day. Because Chaos Search uses your Amazon S3 storage, there is no moving data around, no data retention limits, and you can save up to 80% versus other methods of log analysis. So if you're sick and tired of your elk stack falling over or having your data retention squeezed by increasing costs, then visit chaossearch.io today and join the log analysis revolution. So as you work on the runtime itself, are there room for you guys to do additional optimization around the cold start time? I know the cold start for Ruby is actually very similar to Python and to Node.js as well. But are there anything that you guys are sort of thinking about or maybe doing actively to try to improve the cold start performance for Ruby runtime?
Sure. So yeah, and this was one thing that I was very pleased with as I started to look into the performance of Ruby in general is Ruby, as far as cold starts go, actually performs quite well. So if you look at Ruby itself, the Ruby executable spins up in solidly less than 100 milliseconds. I think Bundler is probably the majority of Ruby's cold start time, and that's been seeing performance improvements as well. But there is an interesting and very common misconception about Ruby where I think some will say like, oh, Ruby's slow, and that's just how it is. And it's actually become not at all true starting from Ruby 2.5 on through Ruby 2.7 as it approaches the anticipated Ruby 3 launch, which probably is coming in the next couple of years. I think that there's some rumors that Ruby 3 is going to drop on Christmas this year. We will see. It'll be exciting if it happens, but there's a big goal called Ruby 3x3 where starting from Ruby 2.0, by the time they got to Ruby 3.0, they wanted to see a 3x improvement in performance, and they're actually quite close to achieving that. So, and I've had a lot of interesting conversations with people working on the Ruby team, and they're actually very mindful about the cold start performance of Ruby itself in general, and that's had a lot of benefits. But I think in the context of writing a runtime and really trying to optimize cold starts, I mean, a lot of that is just how much work is your executable doing before it takes on customer code, and really trying to minimize that, be mindful of not doing expensive operations that you don't need to be doing. And this is actually it's much the same to how you minimize cold starts in an application you write. There's a lot of simple best practices like do your initialization outside of your handler so that you're not repeating work and reducing the performance of your functions by doing work inside the handler that can happen outside of it, or being mindful of like doing a whole bunch of state loading when you're launching an application. Like, can you minimize the amount of state that your application needs to hydrate to function? So I think a lot of the same concepts apply, because at the end of the day, it's just an executable that you're spinning up inside the execution environment.
So that's actually quite good advice that you just mentioned in terms of doing initialization out of handlers so they don't repeat them, and also minimizing state loading during initialization as well. Are there any other sort of tips that you can give to your customers who are looking to improve cold start performance for their Ruby runtime? Anything that's maybe specific to Ruby? I don't know, because we've known when you use a bundler, it improves the cold start a lot because it removes all the runtime file I/O you gotta make when you require dependencies. Is anything something similar to Ruby?
So I think the biggest thing I've seen for Ruby is power tuning. Like, it's a very common trope, but Ruby is actually, interestingly, the language is fairly good about being conservative about its CPU and memory usage. Like I've sometimes seen minimum memory settings actually give you pretty decent performance with the Ruby runtime, which is interesting. But power tuning, and for those unfamiliar, there are some tools I think Alex Casalboni released that help you run the same function at different memory CPU settings to kind of find out what's going to give you the optimum performance and the optimum price efficiency of running your Lambda functions. And that's definitely very valuable. I think also within Ruby, a couple of elements are thinking about when auto-loading is appropriate. Auto-loading being lazy loading of different dependencies and files. That can give you performance benefits over the lifetime of a execution environment, especially if you have many dependencies that are quite large. Another interesting thing is that Ruby is actually starting to do a lot of this heavy lifting in recent versions. So I am very interested to see more benchmarks coming in about Ruby 2.7, the language, where they've really started to work on just-in-time compilation optimizations, which really shine when you repeat similar code paths over and over, which is almost the classic definition of how a lot of Lambda functions work. You're kind of repeating a very similar code flow over and over. And so I think that Ruby 2.7 and later versions are actually very well suited for the Lambda compute model.
Okay, yeah, I'm a big fan of power tuning, and I'll include the link to power tuning in the show notes for anyone who's not seen it before. But I guess for as far as cold start is concerned, because the Lambda runs the initialization with full CPU, so I've actually not found much difference when it comes to cold start performance using more memory, except for, strangely, for .NET Core. That seems to be the only runtime that if you put more memory, it cold starts faster. Haven't quite figured out why that's the case. But the other runtimes, when I've done benchmarks before against them before, the memory doesn't seem to affect the actual cold start time itself very much, because the initialization is always running at the full CPU. Any idea why that's the case with .NET Core, why that's the one that's different?
I don't have a lot of personal familiarity with .NET Core, but I think the reason that power tuning remains valuable for actual real-world application cold starts is that a lot of what you're experiencing as the cold start, like the first run of your Lambda function, is also what is all of your initialization code. If you are loading up a large number of libraries, if you're loading up a large number of configuration files, you're essentially doing compute operations as a part of your getting your function ready to take traffic. So power tuning, if you have a lot of code doing that, can still be very valuable because you are speeding up the code that you're running before you take traffic. And of course, another solution, if you are very sensitive to the impact of cold starts in your application, if you have very high performance requirements going from like the P99 percentile and upward, for example, options like provision concurrency work really well because you can worry less about how much work am I going to do hydrating my function and configuration and state before I can take traffic, and kind of leave that to happen before, like at scale, not as the traffic comes in.
Okay, and since you mentioned that you had so much fun building the Ruby runtime, so what led you to switch gears and move to the SAM team instead?
Yeah, for sure. I think it kind of goes back to the thing that has me really excited about serverless. So if I were to kind of break up the arc of my career, so working in Amazon retail, working on inventory planning and management algorithms, it's a very high scale system. There's a lot of traffic that we serve doing that. And what I found very interesting, especially as a very junior engineer at that point, there's a lot of standing on the shoulders of giants. There's a lot of very talented engineers at Amazon that have built a whole bunch of very robust systems that you can kind of build on top of. As I transitioned into working on the Ruby SDK and open source, the question that really started to become a passion of mine was, okay, how do I, from scratch, from a blank slate, make applications that are extremely robust, that are highly performant, that scale really well, that deal with all the types of fault tolerance problems that can happen? And it kind of leads you on that journey through, I'm learning how load balancers work. I'm learning how auto-scaling works. Like, what happens if a bunch of your servers go down, or if you deploy a bug and you need to adjust to that and try to like avoid downtime. And I think for me personally, I found a lot of the process of making these extremely robust production systems difficult. There's a lot that you have to learn, and like the learning curve for me was very steep. And it's something that I pressed on with for many years, and starting to get the hang of it, starting to learn this, starting to think about how can I build tools that make this more reachable and accessible. And then it's almost like I had the light bulb eureka moment at a point when I was working on the Lambda runtime for Ruby of, this really just gets rid of whole swaths of problems that I've been having to deal with before. The idea that the scaling is handled on your behalf, fault tolerance. I mean, an interesting problem with designing load balancers and servers, for example, is how do you decide when to take a server out of rotation behind a load balancer? Like, you start to see 500 errors coming back from it, but do you take it out of service right away? Do you wait? Like, optimizing that can, like if you over optimize that, you could take all your servers out of service from a like short transient bug and now you're completely down. Or you wait too long and 10% of your customers are hitting bad servers. And there's a lot of work and a lot of creativity that goes into designing these systems well. And when you look at like an API gateway Lambda model, like if you have something that crashes a Lambda execution environment, it'll just be taken down and the next request will get a new one. And that type of model, the number of problems you have to solve to get to that performant, high scale, fault tolerant system is not zero, but the space of problems you have to solve is so much smaller that I feel like a single developer can really start to reason about all the different things you need to understand to make these kinds of production quality systems. And once I realized like, oh, I can really do this, that was this really exciting moment for me where it's like I can write a demo application and it can take thousands of concurrent users from the moment I deploy it, which is just, it's incredible. Like if you would have told me 10 years ago that this was going to be possible, it would just sound like magic to me. I wouldn't be able to reason about it.
And that's definitely why I love Lambda so much, is that I can give all the complex problems of building a highly resilient, highly scalable system to you guys. But what is it like to, I guess in that case, to work as an engineer at AWS and be on the receiving end of all that complexity for building these complex, highly resilient systems, and also be on call for them, because when things go wrong, you guys are on the hook to fix things very, very quickly, which credit where credit is due. But what is it like to be on the hook for all these different customers and having to deal with all this complexity?
Yeah, it's incredibly interesting. And almost like going back to the question of why I joined then, it was, realizing that serverless had all this potential and then thinking there's a little bit of a learning curve for me to get the hang of it. And what I became very excited about is making the tooling to make this as easy as possible. And I'm really excited about the potential of some of the things that we can do to, take the current state and make it easier and easier and easier. And I think like being on the other side, like kind of seeing what goes into making this, I feel like I'm learning all the time. Like the thing that I have said to my managers, and I'm hoping I'm not stepping out of line by saying this, is that if I stop learning, then I think I'm going to quit and do something else. So I'm still around, so I'm still learning every year and, sometimes every day. And, it's also just surrounded by people who have just incredible brains. Like the amount of creativity and intelligence that I see in the engineers that I work with is super inspiring and kind of like pushes me to be a better engineer. So like, I think that's the thing, is like working on AWS is just, there's a lot of learning that goes into it. It's very exciting to kind of be able to have that broad impact of making so many developers' lives easier, and kind of like learning how we accomplish that, and then trying to even take those best practices and build it into the products that we give people. Like anytime we solve a new or I see a creative solution to a problem about, how do we get high performance? How do we deal with scaling? How do we deal with interesting failure cases? It becomes, how do we then make that accessible to all of our customers? How do we externalize lessons that we've learned? And it then gets built into our services. It gets built into our tools. There's interesting things like the Amazon Builders Library that I think we announced at the last reInvent that we announced recently, where a lot of our principal engineers like share deep lessons that they've learned about building reliable software. So like that's the thing that I get excited about, is learning all these interesting ways to solve problems and then sharing it.
I bet there's very few places where you get to work on really challenging, very interesting problems like you guys do at AWS. So I guess our final question is what color would your badge be if you stay there for another 10 years?
So I believe that my badge color would become gray. We do have a teammate of mine that I work with who has been at Amazon for over 20 years, and yeah, it's a lot of very interesting conversation. Like, I think like any company that's been around that long, it's very interesting to see kind of how teams change, how cultures change, and like the kind of lessons you learn from being at a company from its early days all the way through the maturity and scale that we've reached. So yeah, if I'm around another 10 years, it'll be interesting to see what even software development looks like at that point.
Maybe at that point, I just tell Alexa what I want, and then she would just build it for me.
It's good. It's going to be an interesting world. Like I'm really excited to see about like the types of things that are possible for making building these types of high scale systems more and more approachable. Like, it'd be incredible if we get to a point in a few years where you don't even have to think about it. You're just writing your code, and you get to the point where you feel like scale and fault tolerance and all these things are solved problems. It's a difficult dream to reach, but the possibilities of it are really exciting.
So thank you so much, Alex, for joining us today and sharing so much of your experience.
Yeah, thank you so much for having me. It was great.
So before you go, how can people find you on the internet?
Yeah, so you can find me on Twitter at Alex W. Wood, so 2 W's in the middle, the joys of a common name. And you can also find me on the web at alexwood.codes, where I occasionally blog about things I learn or find interesting, but occasionally. I'm working on getting more consistent about that. But I'm definitely very active on Twitter, and I enjoy hearing from people about the things they're building, successes people are having, or even things that we could do better and things that you'd want to see us build. It really does have a real impact on what we build to hear feedback from customers about what they'd like to see, what they find frustrating, or even like what they find exciting that they'd like us to double down on. So I really do enjoy hearing from people about that kind of thing.
Excellent. And I'll put those in the show notes. And like Alex said, if you got any interesting things you want to ask Alex, please get in touch with him on the social media. And once again, thank you so much, Alex. I hope everything is safe where you are.
Yeah, thank you so much.
Take it easy. Okay, bye-bye.
Bye.
So that's it for another episode of Real-World Serverless. To access the show notes, please go to realworldserverless.com. If you want to learn how to build production-ready serverless applications, please check out my upcoming courses at productionreadyserverless.com. And I'll see you guys next time.